According to National Electrical Code Article 410.120a, tanning beds require a readily accessible disconnecting means within sight of the appliance and within 6 feet, which is approximately 1.83 meters, of its point of attachment to the flexible cord. This means that a disconnect switch must be installed near the tanning bed, specifically within 6 feet of the location where the flexible cord connects to the appliance. The purpose of this disconnect switch is to provide a readily accessible way to shut off the power to the tanning bed in an emergency situation. Now let's delve into the allowed methods for achieving this requirement. Firstly, a disconnect switch should be installed directly in the line that feeds the tanning bed. The crucial aspect is that this disconnect switch must be positioned within 6 feet of the point where the flexible cord connects to the appliance. Secondly, if the tanning bed is permanently wired, meaning it does not utilize a flexible cord for its connection, an exception exists. In this case, the circuit breaker panel can serve as the disconnecting means. However, this exception is contingent upon the circuit breaker panel being within sight of the appliance and meeting the accessibility requirement as defined by the National Electrical Code. In conclusion, the general rule is that a disconnect switch is required within sight of the tanning bed. The only exception to this rule arises when the tanning bed is permanently wired and the circuit breaker panel is both within sight and readily accessible. It's important to adhere to these guidelines to ensure safe and compliant electrical installations for tanning beds. Proper installation of electrical components is paramount to ensure safety and compliance with electrical code. Firstly, it's imperative to understand the specific requirements outlined in the National Electrical Code, specifically Article 410.120 pertaining to tanning beds. This code mandates a readily accessible disconnecting means within sight of the appliance and within 6 feet of the point where the flexible cord connects. Secondly, determine whether the tanning bed is permanently wired or utilizes a flexible cord. This distinction influences the acceptable methods for providing the required disconnecting means. If the tanning bed is permanently wired, the circuit breaker panel can serve as the disconnecting means, provided it meets the visibility and accessibility criteria. Thirdly, for tanning beds using flexible cords, a disconnect switch must be installed in close proximity, specifically within 6 feet of the point where the flexible cord connects to the appliance. This ensures a readily accessible means to de-energize the tanning bed in case of emergencies. Fourthly, the disconnect switch should be clearly labeled and easily identifiable. This helps users and maintenance personnel quickly locate and operate the disconnect switch when needed. Fifthly, all wiring and connections must adhere to the specifications outlined in the National Electrical Code. Use appropriate wire gauges, connectors, and grounding techniques to ensure a safe and reliable electrical connection. Sixthly, inspect the flexible cord for any signs of damage or wear. Replace any damaged or frayed cords immediately to prevent electrical hazards. Seventhly, verify the voltage and amperage ratings of the tanning bed to ensure compatibility with the electrical circuit. Use a circuit breaker with the appropriate amperage rating to protect the tanning bed from overcurrent conditions. Eighthly, ground the tanning bed properly to minimize the risk of electric shock. Connect the grounding conductor to a suitable grounding electrode system as specified in the National Electrical Code. Ninthly, test the installation thoroughly after completing the wiring and connections. Use a multimeter to verify proper voltage levels, continuity, and grounding. Tenthly, provide clear instructions to the users of the tanning bed regarding the location and operation of the disconnect switch. Emphasize the importance of using the disconnect switch in case of emergencies. In addition to the specific requirements for tanning beds, several general electrical safety considerations should always be taken into account when performing electrical work. Firstly, always de-energize the circuit before working on any electrical components. Use a voltage tester to verify that the circuit is indeed de-energized. Secondly, use appropriate personal protective equipment, including safety glasses, insulated gloves, and appropriate clothing. This helps protect against electrical shock and other hazards. Thirdly, never work on electrical systems while standing in water or on a wet surface. Water is a good conductor of electricity and increases the risk of electric shock. Fourthly, avoid overloading electrical circuits. Overloaded circuits can overheat and cause fires. Distribute electrical loads evenly across different circuits. Fifthly, use extension cords sparingly and only for temporary purposes. Avoid running extension cords under carpets or across walkways where they can be damaged. Sixthly, inspect electrical cords and plugs regularly for any signs of damage. Replace any damaged cords or plugs immediately. Seventhly, never attempt to repair electrical equipment unless you are qualified to do so. Electrical repairs should be performed by a licensed electrician. Eighthly, install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs can detect ground faults and quickly shut off power to prevent electric shock. Ninthly, keep electrical panels and outlets free from obstructions. Do not block access to electrical panels with furniture or other items. Tenthly, have your electrical system inspected regularly by a qualified electrician. Regular inspections can help identify potential problems before they become serious hazards. When working with electrical systems, it's essential to have a solid understanding of basic electrical principles. Firstly, voltage is the electrical potential difference between 2 points in a circuit measured in volts. It represents the force that drives electric current through the circuit. Secondly, current is the flow of electric charge through a circuit, measured in amps. It is directly proportional to the voltage and inversely proportional to the resistance. Thirdly, resistance is the opposition to the flow of electric current in a circuit measured in ohms. It limits the amount of current that can flow through the circuit for a given voltage. Fourthly, power is the rate at which electrical energy is transferred or consumed in a circuit measured in watts. It is equal to the product of voltage and current. Fifthly, Ohm's law describes the relationship between voltage, current, and resistance in a circuit. It states that voltage equals current times resistance, or volts equals amps times ohms. Sixthly, series circuits are circuits in which components are connected one after the other, so that the same current flows through all the components. The total resistance of a series circuit is the sum of the individual resistances. Seventhly, parallel circuits are circuits in which components are connected side by side, so that the voltage is the same across all the components. The total resistance of a parallel circuit is less than the resistance of the smallest individual resistor. Eighthly, alternating current or AC is a type of electrical current that reverses direction periodically. It is the type of current used in most household and commercial electrical systems. Ninthly, direct current or DC is a type of electrical current that flows in one direction only. It is the type of current used in batteries and electronic devices. Tenthly, grounding is the process of connecting an electrical circuit to the earth, which provides a low resistance path for fault current to flow back to the source. Grounding helps to prevent electric shock and protect equipment from damage. When working with electrical systems, it's also important to understand the different types of wiring methods. Firstly, non-metallic sheath cable, or NM cable, is a type of electrical cable that consists of 2 or more insulated conductors enclosed in a non-metallic sheath. It is commonly used for residential wiring. Secondly, metallic sheath cable, or MC cable, is a type of electrical cable that consists of 2 or more insulated conductors enclosed in a metallic sheath. It is commonly used for commercial and industrial wiring. Thirdly, electrical metallic tubing, or EMT, is a type of metallic conduit that is used to protect electrical wiring. It is commonly used for both residential and commercial wiring. Fourthly, rigid metal conduit, or RMC, is a type of heavy-duty metallic conduit that is used to protect electrical wiring in harsh environments. Fifthly, flexible metal conduit, or FMC, is a type of flexible metallic conduit that is used to protect electrical wiring in areas where flexibility is required. Sixthly, liquid-tight flexible metal conduit, or LFMC, is a type of flexible metallic conduit that is covered with a liquid-tight jacket. It is used to protect electrical wiring in wet or damp locations. Seventhly, underground feeder, or UF cable, is a type of electrical cable that is designed for direct burial in the ground. It is commonly used for outdoor lighting and other outdoor applications. Eighthly, service entrance cable or NEC cable is a type of electrical cable that is used to connect the utility power source to the building's electrical system. Ninthly, armored cable or AC cable is a type of electrical cable that consists of insulated conductors wrapped in a layer of metal armor. It is commonly used for residential and commercial wiring. Tenthly, cable trays are structural systems that are used to support and route electrical cables. They are commonly used in industrial and commercial applications. When selecting wiring methods, it's important to consider the environment in which the wiring will be installed. Factors to consider include moisture, temperature, chemical exposure, and physical damage. In addition to understanding wiring methods, it's also important to be familiar with the different types of electrical components. Firstly, switches are devices that are used to open and close electrical circuits. There are many different types of switches, including toggle switches, rocker switches, dimmer switches, and smart switches. Secondly, receptacles are devices that are used to provide a point of connection for electrical appliances and equipment. There are many different types of receptacles, including standard receptacles, ground fault circuit interrupter or GFCI receptacles, and USB receptacles. Thirdly, lighting fixtures are devices that are used to provide illumination. There are many different types of lighting fixtures, including incandescent fixtures, fluorescent fixtures, LED fixtures, and track lighting. Fourthly, circuit breakers are devices that are used to protect electrical circuits from overcurrent conditions. When a circuit breaker trips, it interrupts the flow of current to the circuit, preventing damage to equipment and reducing the risk of fire. Fifthly, fuses are devices that are used to protect electrical circuits from overcurrent conditions. When a fuse blows, it melts and interrupts the flow of current to the circuit. Sixthly, transformers are devices that are used to step up or step down voltage levels. They are commonly used to convert high voltage power from the utility grid to low voltage power for use in homes and businesses. Seventhly, motors are devices that are used to convert electrical energy into mechanical energy. They are used in a wide variety of applications, including appliances, machinery, and vehicles. Eighthly, generators are devices that are used to convert mechanical energy into electrical energy. They are commonly used as backup power sources during power outages. Ninthly, control panels are enclosures that house electrical control equipment such as circuit breakers, relays, and timers. They are used to control and monitor electrical systems in industrial and commercial applications. Tenthly, grounding electrodes are conductive objects that are buried in the earth and connected to the electrical system. They provide a low resistance path for fault current to flow back to the source, helping to prevent electric shock and protect equipment from damage. When selecting electrical components, it's important to consider the voltage, amperage, and wattage ratings of the components. These ratings must be compatible with the electrical system in which the components will be installed. Additionally, it's important to choose components that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listed components have been tested and certified to meet safety standards. Finally, when working with electrical systems, it's crucial to follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical installations. It provides detailed requirements for wiring methods, grounding, overcurrent protection, and other aspects of electrical safety. Local jurisdictions may also have their own electrical codes and regulations, which must be followed. Adhering to electrical codes and regulations helps to ensure that electrical installations are safe and reliable. It also helps to prevent electrical fires and other hazards. In addition to the technical aspects of electrical work, it's also important to have good communication skills. When working with clients or other stakeholders, it's important to be able to explain electrical concepts clearly and concisely. It's also important to be able to listen to their concerns and address their questions. Good communication skills can help to build trust and ensure that projects are completed successfully. Electrical work can be dangerous, but by following safety precautions and using the proper tools and equipment, you can minimize the risks. Always work safely and take the time to do the job right. With proper training and experience, you can become a skilled and competent electrician. The information provided is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific electrical projects or installations.